Welcome back to Kids Fun Science. My name's Ken. Today's experiment is, does ice cubes melt faster in fresh water or salt water? As always, adult supervision is required. What you need for this experiment is colored ice cubes, salt, and transparent cups. Now ask yourself the question, do they melt faster in fresh or salt water? And while you get that answer going, to set it up, we need two glasses filled with regular tap water. In one of them, we're going to pour salt, hence the whole name of the experiment, right? Salt water, and on to the left is regular tap water. Both are regular temperature, straight out of the tap, so there's not hot or cold. Just have salt in one of them. And then after that, I froze last night. I froze some blue ice cubes. And I'm going to put one ice cube in each one. So I hope you got your guess there to see which one's going to melt faster. Of course, you could tell the fresh, clear tap water is on the left and the salt water is on the right. And we can see that it definitely kind of looks from the beginning that the regular tap water is it looks like it's melting because we can see the stream, but we don't see much. It is murky on the saltwater side. So we'll continue to watch this, and while we do, I'm going to tell you the science behind it. So the science behind this. Well, I love the results of this experiment because it really surprised me. When I put salt on an ice cube, it melts the ice cube very fast. So when I saw this experiment, I couldn't believe my eyes. So the ice cube in the salt water started melting much slower than the one in the fresh water. In the salt water, the colored water from the melted ice cube formed a distinct layer that floats on top of the salt water, as you can see on the right-hand side. In the fresh water, it melted and sunk to the bottom and spread out evenly. These observations can be interpreted by comparing the density of the fresh water and the salt water. When the ice melts, the water that results is very cold. It is more dense than the warmer tap water that is in the cup, and thus will sink, as we see on the left-hand side. As the colder water sinks, it displaces and pushes the warmer tap water from the bottom. As the warmer water comes in contact with the ice cube, it hastens its rate of melting and pushes up, the convention of the transfer of the heat by the movement of the fluids. As for the cup on the right, the salt water, the cold water that results from the melting of the ice cube is less dense than the salt water, so it floats on top. There is no convection currents occurring here, since the ice cube is constantly in contact with the very cold water, which prevents it from contacting the warmer water below, which takes longer time to melt. The same effect happens in the oceans, where icebergs last much longer in salt water than they do in fresh water. The melted ice from an iceberg will float on top of the salt water in the ocean, but it will sink in the fresh water. Same effect with the soda drinks. Ice cubes will cool a diet drink much faster than they will a sugar drink for the same reason. So that's what the science is behind this experiment, and you can see here as we finish up, on the left-hand side, the regular tap water, the ice cube is just about gone. And I will show you the ice cube on the salt side is probably only 2/3 of the way done. So it does melt a lot faster in regular tap water than it does salt water. And here you are, you can see the regular salt water first on the side here. It's got that thick layer. There's the ice still, so it didn't completely melt the whole ice cube, where there's absolutely no ice cube left at all in the regular tap water. I hope you enjoyed this video. Remember to click thumbs up or share if you like it, and thanks for watching.